Hi, I'm Mike Holland, one of the solution engineers with the NGINX business unit, part of F5 Networks. Today, I'd like to talk about microservices using the NGINX Plus Kubernetes Ingress Controller. So with NGINX, we have our NGINX open source offering, as well as our NGINX Plus offering, commercial offering. And the differences between the two are several features are offered in Plus, not in open source versions, such as active health checks, key value store, session persistence, and so on top of support, so commercial support for NGINX Plus. Now, the same is true for our NGINX Ingress Controller. We have an offering with open source, as well as an offering with Plus, with the similar differences to what I mentioned before. So today we're going to do a demonstration using the NGINX Plus Kubernetes Ingress Controller. Now, the Ingress Controller in a Kubernetes environment has a very important role of controlling the north-south traffic between your clients, your customers, and your web applications. And that provides an opportunity there to really add a lot of security and functionality to monitor that traffic coming in and out of your Kubernetes cluster. Now, when we deploy a Kubernetes Ingress Controller, we deploy it as a pod that runs within your Kubernetes cluster. So when you need to scale out and you need to scale in, you're able to increase the number of pods or decrease the number of pods based on the amount of traffic and the requirements for your web applications. Then I want to talk about how that important north-south traffic and being able to provide a lot of security and a lot of benefits to that traffic. So some of those benefits include authentication and authorization. So things that we have in the NGINX Plus version include JOT validation, which is also included in the NGINX Plus Kubernetes Ingress Controller. So being able to not only authenticate that JOT, ensure that it's valid, but to take specific claims out of that JOT and then use those claims to make decisions as to what applications and what paths into those applications are accessible by the person who used the JOT. Another value and security offering that we can add to the NGINX Kubernetes Ingress Controller is our web application firewall, referred to as NGINX AppProtect. And this allows us to apply a mature web application firewall right at the entrance point to your Kubernetes cluster. So our NGINX AppProtect is a dynamic module that can be bolted on to any NGINX Plus instance that you have installed in your environment, including the Kubernetes Ingress Controller. Based on years of experience and a very mature product, that being the advanced WAF on our Big IP platform, we recompiled the code for that to run on our NGINX proxy. And the advantage of doing that is that we were able to take all those attack signatures that have been created for advanced WAF, all that customer feedback, all that feature creation over the years, and recompile it and add all those same features and attack signatures into our NGINX Plus product. So the lab environment that I have set up today, of course, has a few of our NGINX Ingress controllers, has a web application deployed so that I can demo web application firewalls, rate limiting. But it also, since we can deploy more than one pod, remember the use case where I talked about scaling out and scaling in, we need to have a way to load balance those pods and externally. So if we have one pod, it's no big deal. We can access that pod directly, maybe using a node port type of service, and get access to our applications. But when we start scaling out to handle larger volumes of traffic or maybe multiple applications, we need to have an external load balancer type to load balance those pods. And in our case, being a part of F5 Networks, I've used the F5 Big IP LTM in correlation with F5 Container Ingress services to allow that external load balancer to communicate with our Kubernetes cluster. And one of the ways that we configure these NGINX Kubernetes Ingress controllers, as well as the external load balancer, are using custom resource definitions. Now, custom resource definitions are a way of adding features and functionality for specific vendor offerings. So now if you have, say, for instance, a standard Kubernetes API resource like an ingress object, it's very generic such that it can support a multiple range of Kubernetes Ingress controllers for multiple vendors. But when you start to add functionality and you want functionality specific to vendor deployments, such as Kubernetes or NGINX Kubernetes Ingress Controller, you want to add custom resource definitions so that you can allow those features to come out and be easily configured by your Kubernetes administrators, by your DevOps teams, by your NetOps teams, by your SecOps teams, all in that same format of using manifests or Helm charts, all from that Kubernetes API. So we have custom resource definitions defined for our external load balancer. We have custom resource definitions defined for our NGINX Ingress Controller. We have them defined to configure virtual servers and virtual server routes, as you'll see here. We also have them available to configure things like NGINX AppProtect WAF policies, rate limiting, JOT validation, mutual TLS, and so on. And really that allows you to take a configuration such as NGINX AppProtect and simplify it down into that custom resource definitions. Without custom resource definitions, really our only choice is to use annotations in the Kubernetes default ingress object, which can really start to not scale very well as your configurations for your applications start to get more and more complex. So custom resource definitions really allow you to simplify the deployment of your applications end to end. Another thing it adds is the ability to take these different manifest Helm charts, store them in a Git repository, and then allow access to specific parts of your business, different personas, to access those manifests and make configuration changes for a seamless end-to-end deployment. So what this allows us to do is the DevSecOps can look at the WAF policy configurations, the NetOps can look at the Ingress object configurations, those virtual server custom resource definitions. And then your DevOps can take care of your deployments, your services for an end-to-end application. Let's jump right into a demonstration. All right. So I mentioned before that I'm running a Kubernetes environment with NGINX Ingress Controller. And one of the things I have deployed here is a few pieces, right? I mentioned the external load balancer, it's big IP LTM. I mentioned the NGINX Kubernetes Ingress Controller. I mentioned the container ingress services, which allows that Kubernetes interface to talk to our external load balancer. But I also wanted to mention that I'm running a 3-node environment. So I got 2 worker nodes and a control node, right, based on Rancher's Kubernetes deployment. So with that, if we have a look at the environment, let's just have a look at the nodes I have deployed here. And we'll just widen them out here so we can show a bit more detail. Again, I'm using aliases, so you won't see the kubectl typed out because as a male, I really struggle to talk and type at the same time. I just asked my wife. But you'll notice here, there's 4 nodes listed, right? So we've got those 2 worker nodes, right? Knode 1, Knode 2. We've got that control node, kmaster. But we've also got that external load balancer added to there. And that allows that external load balancer to talk to our Kubernetes ingress controllers using cluster IPs as opposed to node ports. So we can avoid using that kube proxy. Another advantage of that is our external load balancer can health check each of our NGINX Kubernetes Ingress Controller pods individually. If we had deployed 4 Kubernetes NGINX Ingress Controllers, we would actually only see 3 of them if we had deployed our external load balancer using node port. But since we've deployed it using cluster IP, we can see all 4, even though 2 of those NGINX Kubernetes Ingress Controller pods reside on the same node in our cluster. So let me show you an example of that, right? So if we look at our pods and we look at the pods in our NGINX Ingress name service, we'll see here, I've got 4 NGINX Kubernetes Ingress Controller pods running. And we'll just widen that out to get a bit more information. We'll see that 2 of those pods are currently running on the worker node 2. But when we look at our external load balancer, we can come in here and we can see that the pool members have been configured. And if we just refresh here, we'll see that we have 4 members in here actively being health checked. And we can see that that's all created using that custom resource definition. So it's an object defined as an ingress link. So if we jump back into here, we can have a look at our API resources. And we can see that we've got several mixture of several default Kubernetes API resources, as well as a few that have been added by not only our NGINX Kubernetes Ingress Controller, but our external load balancer. And we can filter those out here by just piping to grep and looking at just the F5 and NGINX custom resource definitions. So I just want to highlight a few while we've added these in here. I just want to highlight a few of them that we're going to use today in today's demo. So I showed on one of the slides here our virtual servers custom resource definition created by NGINX to allow more configuration of NGINX features in that ingress controller. I also mentioned quickly here those ingress links here created by F5 to configure our external load balancer from Kubernetes. Also wanted to highlight the AP policies listed here, stands for AppProtect policies. And those are the custom resource definitions we'll use to configure our web application firewall in our environment. Now, each of these add features and functionality specific to, say, maybe you want to use a TCP server, right? You want to have a TCP service or a UDP service within your Kubernetes environment. You want to allow that traffic through. Of course, not all of our applications at the end of the day are HTTP web applications. So we want to be able to ensure that we can also support TCP as well as UDP applications in our NGINX Plus Kubernetes Ingress Controller. So jumping along here, I just wanted to show, so you saw we had 4 Ingress controllers deployed. And if we go in, we've got that Ingress link custom resource definition deployed. It defined our listening IP address. But now if we go in and we say, okay, you know what? I need to scale down. It's late at night. I got less traffic coming into my environment. Let's see what that looks like, right? So if I go in, I have a look at my deployment definition for my Ingress controller. And you can see here what we have defined here is, of course, we're saying we got the name NGINX Ingress. We got a special namespace for the Ingress controller to be deployed in. And if we just jump down to a few highlights here, we can see our image is referencing an internal repo to pull our Ingress controller pod out to be deployed. So that's real important because when we have our commercial deployment of our Ingress controller, we need to make sure we keep those license keys secure. So using an internal registry for your NGINX Plus Kubernetes Ingress controller is a must for sure. As we jump down here, we can see here we've named our containers, and we can see we've got the standard ports open. So we've got 80 and 443 open for our HTTP applications, web applications. But these next 2 ports here, the first one being our readiness port, port 8081, allows our external load balancer, and in this case, it could be any external load balancer. If you're deploying the NGINX Kubernetes Ingress Controller in an on-premise environment like I have here, you might be deploying it in the Google Cloud, a Kubernetes environment, in Azure, an AWS Kubernetes environment. It would all work the same at the end of the day, but that external load balancer, whichever one you decide to use, needs to be able to tell if the NGINX Ingress Controller pods are available. And that's what that readiness port is for. So when you're scaling up and down, it may take a second or two for those pods to deploy and be able to start accepting traffic, right? Because they got to deploy, they got to configure. So the readiness probe allows our external load balancer to determine when those pods come online and when those pods are able to start passing traffic before sending the traffic to them. So it's real important to have that readiness port. The last port here I'll mention is Prometheus port. So this allows our Prometheus exporter to scrape messages or metrics based from our web applications, right? To get a full view of how our web applications are performing. And again, with the NGINX Ingress Controller being the main point of entry and exit for your Kubernetes clusters, it's a great location to pull all those metrics from your web applications and how they're performing between the web application and your clients. So just jump down for the last few here. You can see the arguments fields here specify the information we're going to send to the NGINX Kubernetes Ingress Controller when we're starting the pod up. So we've got the obvious stuff here for NGINX Plus, that we're using NGINX Plus and not open source. We're enabling NGINX AppProtect. We're enabling a few custom resource definitions. But I wanted to highlight here the NGINX config maps, because this is important when you do have an external load balancer in front of your NGINX Kubernetes Ingress Controller pods. What this config map does is it provides configuration for all your Ingress Controller pods that are pod wide. And an example of this is using the proxy protocol. And now we use the proxy protocol to ensure that the client IP address making the request for the web service is forwarded all the way through to the web application. And this helps to ensure that logging information is correct. It allows you to make those rate limiting decisions I mentioned before correctly based on the true customer's client IP address. Now, the way that works is when an external load balancer is used, of course, it's just a layer 3 load balancer. It's passing TCP, UDP traffic through. And so it's not going to be able to have the ability to use X-forwarded 4 headers to insert that customer's IP address or that client's IP address into headers, right? At the end of the day, it's just saying a TCP stream. So what the proxy protocol does is send a TCP packet with that true information before sending on the TCP stream, which is, say, your HTTPS traffic back to the Ingress controller. So the Ingress controller is able to read that proxy protocol to get that client IP address out. And then since the Ingress controller is actually doing the SSL offloading, it then has the ability to insert X-forwarded 4 header, an X-real IP header into that traffic so that your backend application can see that. And we'll show a demo of that in a second. So as we jump back to that terminal window, you can see I've got 4 replicas configured here, and we saw that earlier. But let's say I want to scale in. We'll make it 2, right? We had 4, we'll go to 2, and we'll just write that, and then we'll apply it. And once we apply it, Kubernetes API takes that configuration, reads what the difference is, and then starts to make changes to the environment. And if we go back to our external load balancer here and we just do a refresh, we can see that we've gone from 4 members to 2, just like that. And the reverse happens just as quick. So then we have that nice end-to-end connectivity. We're using cluster IPs. We got the proxy protocol in place. So let's look at the demo application that I have deployed here. So the first demo application, if we just have a look at the pods, is a cafe application. Now, this is common application we use in a lot of our NGINX demonstrations. And this application has 2 microservices, coffee and tea. And so I've deployed this using a virtual server. It's got a default listener. So it's a real plain basic configuration, but it goes and shows how we can go and configure. So let's go ahead and do that again. And let's look at all the configurations here. So we can see that we've got the coffee and tea service deployed here, right? Using a cluster IP, which is important because that's what our Ingress controller uses to talk to our backend applications. And then we've, of course, got our coffee and tea deployments here. And then we've got our individual pods. So we've got everything deployed for our cafe application. So just to give you an idea of what that looks like, we can actually go in and check the configuration that's been deployed on the NGINX Ingress Controller instance itself. Now, it's real important to note that the way that Ingress Controller works, give me a second here. The way that works is that when we apply a custom resource definition, so say a virtual server object, we go in and we listen for that. So we have a dynamic module that runs on the Kubernetes Ingress controller, and it listens for those Kubernetes API resources to be applied, right? Those custom resource definitions. And when that's done, we take those definitions, and that dynamic module grabs them and converts them into nginx.conf. So if we go in and look at again, cannot type and talk at the same time. Sorry about that. If we go in and look at one of these pods here, we can go in and see that configuration and how it's been configured, right? With a standard NGINX deployment, our configurations typically stored in the etc NGINX configuration folder. But if we look a bit deeper into the confd directory, and we just look there, we can see that that cafe application's been deployed. And if we have a look, we can see that it is taken those custom resource definitions and it's converted that into that nginx.conf configuration. So you can actually go in and look and see what's been applied after you've applied your custom resource definition. It's a really neat feature there. But we just jump out of there real quick. I can demonstrate what happens with that cafe application. So we can see with that application we've deployed HTTPS. So we've got a certificate there. It is self-signed, so we're going to get the padlock there. But with our self-signed certificate application, we can see we've deployed it here. We can see that we've got some load balancing going on. If I refresh a few times, we can see that server name changes, that server address changes. But what I really want to highlight here is the remote address that is shown and seen by our web application, because basically our web application takes our request, formulates it, and then sends back what it saw. So it saw a remote address of 1042.030, and that's the cluster IP in our environment of our NGINX Kubernetes Ingress Controller. And that's, of course, what the application sees if we didn't use the xreal IP header. And I'll just show you here that the IP of this workstation that I'm sending this request from is indeed the same one we see here in the xreal IP. And again, that's that proxy protocol working all the way through our environment with that traffic. So then if we jump in here to a little web application firewall, let's have a look at what we have deployed here, right? And now I have a separate web app that I'm using, and I'm using this web app to demonstrate web application firewall as well as our rate limiting. So if we have a quick look at our environment, we can see that we're going to use the curl command to resolve our web app.example.com application. So sitting on port 80. And it's that IP address, you might have recognized it before, is the virtual IP address that we've applied to the front end of our external load balancer. So in a production environment, that might be a routable IP address. In our test environment, we're using RFC 1918. So we make that request for that web app, and we can see we instantly get a response back, the text version of that cafe app, which was the GUI version. So this is more of an example of an API type deployment. And we can see that we can send that request. We get the same information back, request IDs. But let's say, you know what, we want to add our web application firewall. So now I've already deployed our web application firewall. I've deployed a default policy. And if we just go in and with that default policy, a lot of 0-day stuff in there to help protect against the OWASP top 10 vulnerabilities, lots of high accuracy signatures applied there. But cross-site scripting is one of them that's applied. So if we just type in here a little cross-site scripting attack example, and we send that, we can see here that we've gotten a block page that's come back from our WAF that has detected the attack and has blocked it, right? So before we got that nice formatted API response with all the information from a web application, and now with the scripting attack, we got that block page. And what's interesting is you might have noticed that when we deployed pods, I deployed one of the pods as a syslog server. So if we have a look at that syslog server, we can go in and have a look at the message that was logged there. So if we go in here, I'm just going to have a look in that syslog server. You can see this is the whole message that we got for that violation. Now, of course, that is quite a rather large message that you see there. And it's a lot of information, right? A lot of overload. Even the block message we got was really formatted to show up in a browser. So we're running an API here. Let's fix this, right? We want to see more information useful to how the attack happened, what happened. We want to see a better response message for our API users. So if we go into this environment, let's just talk a bit about how these configuration files are done. So I mentioned before, I've got a default policy. I got a few more features and functionality added. I've added some functionality. Some of you might recognize Data Guard from our Big IP Application Security Manager or Advanced WAF Firewall. I've added a couple signatures in here, but this is the policy, AppProtect policy definition for our web application firewall. Again, custom resource definition. And then we jump to the log configuration file. So this is our AppProtect log configuration file. It defines the format, the max size. So this is the default one. We saw provide those messages before. And if we look here, this is the WAF policy and how it brings it all together. And one of the things I'll highlight here is not only does it have the name of that AppProtect policy we defined and the name of that log config policy that we defined, but it also defines where to the destination to where sending those syslog messages to. Now, I mentioned before that these are a bit messy here. So let's clean that up here. Let's add some customization. So if you look here, you can see that I've already applied a I've already applied two log conf files. So we've got the one that we did before, and we've got the one that I'm going to use now. And if we have a look at the AppProtect policies, we can see I've already applied a custom one here. So let's go in and make those changes. Now we go into our WAF policy. This is the one we currently have running. And if we go in and we just change the name of the policy here, and I'll go through what's changing these policies here in just a second here. We can apply those. You can see I've got an actual IP address of my syslog service running within my pod. So we save those. We apply them. And while that's all applied here, I'll just jump in and show you the changes that I made here, right? So if we go in here, we can see I updated that AppProtect policy, and what I added to it was a custom block page. That custom block page is better formatted for our API applications. I've also updated our log configuration to provide a custom format string that provides the information that we want to see specific to the attacks that we're getting, right? So much more readable, much easier to do. And this is all customizable. So I'm just showing an example of how we can customize these things. And I've applied these all together on that virtual server policy. So I mentioned before that custom resource definition for that virtual server API resource. So again, you can see here that one of the benefits it adds over the standard Kubernetes API ingress object is that it allows the ability to add these policies, like the WAF policy I defined here and a rate limiting policy we're going to show in just a second. So with those all applied, we can go back in and we can just do validation to see that our application is still working. And we can see that it's up and working as we expected to see before. And if we go through and we do another scripting attack, we can see now that the message that we get is much better formatted for our API responses here. And again, we've got that code there. And if we just go and have a look and see what syslog reported this time, we can see that it's now a much cleaner response. So we can see our syslog message has exactly what was blocked, the request that was made, times and dates, and the exact threat or violation that was detected for the reason that it was blocked. So let's test that data guard feature, right? So if we just go in here and we modify it, let's test and see. So I've got data guard set up not to block, but to instead mask the responses, right? So if we go in and we grab one of our test credit card numbers and we paste that in and we send that request, for some reason my environment's starting to slow down, we can see that that response for that credit card number came back and we've masked that credit card number there in the response. That's that data guard feature. So really neat there. The last thing I wanted to show you today was the rate limiting. Now, of course, I have a rate limiting policy defined here, and I can show you exactly what I have created. And what I've done is I've defined that rate limiting policy for 1 request per second. I want the reject code to be 429. And in here, I've used the default binary remote address. So in our case, that is the NGINX Ingress Controller pod IP address. We could have easily changed that to that xreal IP to make that request specific to the customer. But then if we just make a single request here, we can see that we have a working one. And we can just run it a few times here. And we can see that we send through requests to the row very rapidly, and we start seeing that 429 2-minute requests. So there you go. So we demonstrated the custom resource definitions. We applied them to web application firewall and our Kubernetes Ingress Controller, our NGINX Plus Kubernetes Ingress Controller. And we demonstrated how we can secure that north-south traffic control in your Kubernetes environment. There we go. So thank you very much for your time. And if you do have any questions, I'll be available. Just please add them to the Q&A section, and I'll be happy to answer for you. Thank you.